Hello everyone and welcome back to Kanai's AI Lab. Today I'm here with an exciting machine learning demonstration, specifically decision tree algorithm using Python and Scikit-learn library. For this walkthrough, I'll be coding on Google Colab, a free and powerful platform that's perfect for running Python code in the cloud. We will dive into building a decision tree model that predict heart disease based on various health and lifestyle factors. The dataset contains 500 synthetic patient dataset, which includes the features like age, gender, BME, smoking, exercise hours per week, blood pressure, cholesterol, diabetes, family history, and alcohol consumption. The target of this particular data set is heart disease, which is yes or no. By training this model, we will uncover the pattern that could help healthcare professionals make faster and data-backed decisions, potentially aiding early diagnosis and prevention. So let us jump directly into the coding part. We have libraries now. We are going to import the necessary libraries required to run this decision tree algorithm properly. So let us execute this stuff first. And we have the library pandas for data manipulation and NumPy for numerical computation and matplotlib and seaborn, which is specifically for data visualization. And we have sklearn, it's nothing but scikit-learn. So scikit-learn we will be using for model, that is decision tree classifier in this case. And scikit-learn will be useful for splitting the data into train and test, and also for encoding the data from categorical data into numerical data. Also, scikit-learn we will be using this time for creating the performance metric like confusion matrix and accuracy score. With that, we are connecting with our drive, which is Google Drive. So let me connect the Google Drive. This is called mounting. So the mounting will connect your code to the data where the data is available. You can see here drive, go to my drive. So this is your folder where diseases and the code is available. Now we are going to copy this code path. Path means nothing but where the data is stored. You can use this copy path and taking the link or the path of the data, and you are going to paste here along with the data set name and showing first 5 rows of the data using data.head. So data.head will generate 5 rows of the data, which includes all the columns. Now, we are moving with some basic historical data telling from the data. So with basically visualizing the data. For example, I'm going to take the heart diseases with count. You can see here, when I execute here, I can have heart disease S and no. We can say that the count of heart disease S is little bit on the higher side compared to heart disease no. Also, we are going to plot another chart which is X is heart disease and Y is age. We are going to check whether there is difference between heart disease S and no with age. You can see here, from this data we can say that heart disease is comparatively approximately 2 to 3 year old than heart disease no. So like that you can generate many visuals from the data. So you don't need to worry about hardcore programming. Sometimes we can use the generative AI concept so that code can be generated. For example, I'm just utilizing generative AI within the Google Colab. Need 3 more plots from the above same data. It depends upon how we are prompting there. So basically based upon that, the accuracy of the results will come. Let me search now. So by clicking enter, it will generate the code within second. You can see here the prompt need 3 more plot from the above data. Sometimes some manual fine tuning is needed. Let me check whether it is running or not. It's successfully completed the runs. You can see here there are multiple plots generated. You can see whether this is useful or not in your analysis. With that, we are moving to our next step of encoding the categorical variable. As you know that categorical variable cannot be used directly into the algorithm. Algorithm needs the numerical data. For that, we will be using a particular encoder. In this case, there are a lot of encoders present. We will be using an algorithm, label encoder, which we will be calling as LE from now onwards. So we will be having a for loop where first we will pass which are the column. We need columns in the data where gender is categorical, smoking, blood pressure, cholesterol, diabetes, family history, alcohol consumption, and heart disease. All this column we are going to fit underscore transform, which is nothing but from the existing numerical. For that, suppose if it is smoking, yes or no, smoking yes or smoking no, which will be converted directly into 0 or 1, depending basically based upon the alphabetical order. Since n comes before y, wherever n is there, it will be generating 0. Wherever y will be generating 0, generating 1. That's how this label encoder will work. Now, so with that, we are moving to the next step, splitting the data into training and test. Let us see the code first. You can see here, this is how we can code for splitting the data into train and test. So we will be using some preliminary requirement before that. We need the data first. So we need a data frame called data. This data we are going to split into X and Y, where Y we will call it as features, and sorry, X will be calling as features and Y will be calling as target. In this particular problem, the target is nothing but heart diseases, so that we are assigning from the data heart disease is the target. And the X, we are going to take the data frame excluding the heart diseases. That's what drop function. So we will be using the data set without heart disease. That's why X and Y. Now, after completing the X and Y preparation, data frame X and Y preparation, we are going to split the data into 4 parts. So imagine this is X, this completely part X having 7 or 8 columns, and we have one data frame called Y. Now entire data frame we are going to split into 0.1 factor, which is nothing but 90% will go for train and 10% will go for test. So entire data, suppose if X is there, X out of this will go for X train, and this will be calling as X test. And this also same thing, 90% will go for Y train, and this lower portion will go for Y test. So ultimately we have 4 data frame now onwards, X train, Y train, which will be using for fit function. Both will be using for the fit. You can see here, model training is always on the train data. I need the data frame for training. So for training, we will be using a function called fit. So model.fit. So model, we will be using train, that is X train and Y train. So with that, we are just completed the steps of training the data. Let me close this. Now the splitting is over with a fraction of 90 and 10, and we are restoring the data with the random state function. And I'm calling decision tree classifier from the scikit-learn with a max depth of 3 and random state of again 42 some number, and model.fit between train data of X train and Y train. Let me run this. Model name is now onwards CLF. Now, once the model training is over, we are going to find the prediction. Always the prediction will be on the test data. This time we are going to predict on the text data, which is X underscore test, using the function of predict and model.predict of the data, which is X test. So after that, we will be having a new data frame, which is nothing but Y underscore prediction. We are assigning into a new data frame name as Y underscore prediction. So imagine we have y underscore prediction, which is the output of the prediction, and we have an actual value of y test. So this is nothing but actual versus predicted. So always now this comparison will happen. So comparison, that's why performance evaluation will come. So we have y prediction, which is nothing but after model prediction, which is going to compare with the y test, which is nothing but the new data which is not given to the training. So comparison, by the comparison, either how many numbers predicted correctly, that is we will call as a good classification. So maybe heart disease S actually is predicted heart disease S. Sometime heart disease no predicted, heart disease no in the prediction. So there is something called misclassification. What is misclassification? Heart disease S can be predicted, heart disease no, and same time heart disease no can be predicted as heart disease S. Both are very, very dangerous. This we call it as a misclassification of the prediction. So as a developer or as a data analyst, your role is to reduce the misclassification and increase the good classification. Let me erase all those things. Now let me identify what is my confusion matrix and what is my accuracy score. You can see here with a maximum depth of 3, I have a prediction accuracy of 0.66. And you can see again in this case, this diagonal element 4 plus 29, which is nothing but 33, is always, in this case, is good classification. And 14 plus 3, 17 is misclassification. So good classification is 33 and bad classification is or misclassification is 17. So with that confusion matrix interpretation over, we are moving to another thing, nothing but visualizing the depth or visualizing the tree, which is very, very important for the interpretation purpose. For that, we will be using a function of plot underscore tree, which is directly from the matplotlib. We are going to pass which is our model, and after that, which are the features and which are the names. I know heart disease, yes or no, and the tree has to be filled with some values, and we are giving some font size for visibility. Let me show the tree. You can see here, tree is displayed. You can see depth, last depth, second last, 3, 4. You can see, because since we made this as a 5 maximum depth, it is depth of the tree is become 5 now. So how to interpret this? That is very important. Now let me make this particular picture into full screen. How do we interpret? We need to identify where the stop is completed or the splitting is completed. For me, the splitting is nothing but we can say technically Guinea is equal to 0. So don't worry about this technical term. So this is nothing but a criteria of selection. So now I just wanted to understand where Guinea is 0 or the splitting is stopped. So 0 0.5, 1 point. So meaning that still splitting is possible. In this case, since Guinea is equal to 0, the splitting is completed. You can see here because there is a 11 sample are there, 11 sample. Out of that, 11 goes to S. All 11s are S only and 0 on to no. Splitting is over. Here, this is heart disease S. Now we can say that how it goes. It's very interpretation is possible because this is completely finished. Now let me go to the top. This goes like that. Then after that, it goes. Let me close this again. Now after that, it goes like this only. You can see here, it goes like this. Finally, it arrives on the top. This is nothing but roots of the tree. So if you understand the diagonal, this particular decision tree has concept like a root to the leaves. So on the top, we have something called root, and on the bottom, we have something called leaves. Wherever the Guinea is making 0, the splitting is stopped. That's what we will call as a concept of splitting of the tree. Now, how to interpret once again? We have this chart. Again, we will be coming to the chart. We have this chart, and chart is starting with a splitting based upon which category we can identify once again. The chart is splitted starting age is equal to 35.5 less than or equal to. Whenever age less than or equal to 30.5, yes will go this side and no will be going this side. Once it is goes to this side, again the next criteria taken, BMI less than or equal to 31.598. This splitting is depends upon the criteria in the backend. The algorithm is defined based upon how to split it based upon the Guinea only. So after that, the S will go this side and no will go this side. So first start with age less than 31, then BMI less than 31, which is no condition. When the BMI is greater than 31, age less than 31, BMI greater than 31, then exercise hours per week is less than or equal to 2.0, but this is no. So no exercise. So we'll go to completely prediction of heart disease. Yes, this is how we interpret. And you can do one thing. If you're not okay with this tree, you can just change the tree depth to another number, maybe 6 or 7, 8, suppose 8. And if you're not okay with the working of this algorithm, you can change the label encoder into some other encoding purpose. You can change the test size into 10%, maybe 15%, 20%, whatever it is. And you can run the same with the new different features. Let me check how you can see here when I increase the depth from 3 to 7, it is increase or sorry, decrease the accuracy as well as increase the misclassification. So that model is getting worse when we increase the model depth. So this is one understanding. So this particular picture you can see here, the tree depth. You can do one thing, you can just save the picture and give interpretation how to do a best decision from the decision tree. With that, we are concluding the decision tree classification for heart disease prediction. So how to evaluate a decision tree model and how to prepare a decision tree plot to identify how the decision is taken by the professional to make prediction of heart diseases. Hope the video is valuable to you. So stay tuned for more informative content with Kanai's AI Lab.